choice education, living on the street.
Alright, so now that we've gone over the concepts, let's do an example of finding and analyzing critical points of a function. So we're going to analyze the critical points of the following function of our f of x is equal to x to the third minus 27x minus 20. Okay? So where is a critical point? First of all, that would be a critical point occurs when f prime of x is either equal to 0 or it does not exist. Okay, so let's find our f prime of x first. So f prime of x is it's going to be the first derivative of our function. So that's going to be a 3x squared minus 27. That was supposed to be a 2. 27, there we go. Okay, and then we can factor out a 3 here, so we get 3 times x squared minus 9. We can factor this a little bit further, so we have 3 times x plus 3 times x minus 3. Okay, so here we see that this function is always continuous. It doesn't have any place where it can be undefined, right? There's no fraction where we can get an x on the where we can get a 0 on the bottom. So this we must set it equal to 0. Okay, so f prime of x equals 0 when our x is equal to negative 3 or a positive 3. Okay, so these are our critical points. Okay, so let's keep those in mind. And now we're going to implement what's called our sign analysis. Sign analysis. Okay, so I'll continue this on the next slide. So I'll title it sign analysis because that's such a cool name. So analysis. Okay, there we go. So our critical points, again, just a refresher, we have x equals negative 3 and x equals a positive 3. Okay, so what we're going to do for sign analysis is basically draw a number line. Okay, great. So then we're going to put, kind of just plant our critical points there and put dashes by them, okay? So we have our negative 3 and our 3. This is like our x line, okay? And this is going to be, actually I'm going to write f prime of x, okay? So you will see later on that we can do a sign analysis for the second derivative as well. That tells us different things. But anyways, we'll just stick with the first derivative for now. So we have our f prime of x. This is what we're analyzing, right? So what we're going to do now, after we draw our number line and we plant our critical points on it, what we're going to do is kind of just pick easy numbers. That sounds a little bit weird, but we're going to pick easy numbers in between these intervals. So going to the left, this basically goes to negative infinity, and to the right goes to positive infinity. So what I usually do is pick one whole number to the left of whatever my leftmost critical point is. So here I'm just going to pick a negative 4. And then anything in between where we pass from negative to positive, I usually just pick 0, because zeros are fun. Okay, and then let's pick a positive 4 over here, okay, just for the heck of it. So now what we're going to do with these points is we're going to look at the points that we picked, okay, the easy points. And the point of picking these easy values is to make your life easier, basically. So what we're going to do with these now that I just circled is we're going to plug these into our f prime of x, okay? So we're going to plug chosen values. These are the chosen ones. Plug chosen values into our f prime of x, okay? So let's do that. Let's start with our negative 4. So if we do f prime of negative 4, here's a refresher. So f prime of x was equal to a 3, so 3x squared minus 27. Okay, so that was it up there. Just a refresher. So if we plug in a negative 4, we get 3 times negative 4 squared minus 27. So this is going to equal a 3 times 16 minus 27, which is 48 minus 27, which is a 21. And this is a positive number, okay? So this is a positive number, and that's the important part. The sign is the most important. You don't really even have to know this 21. It could be like 2. And just as long as it's a positive number, great. We're just going to roll with it. So anyways, so we found out that that's 21, which is a positive number. So what we're going to do now is stick a positive number, a plus sign, right above that negative 4, the one that we plugged in. Okay, so let's do the same thing for 0 and the same thing for positive 4. So now we'll do f prime of 0. This one's always fun. So we just plug in a 0 there. Yay. And then we have minus 27. So this turns out to be a negative 27, which happens to be a negative number. So we're going to put a negative sign right above that 0. Okay? And now lastly, we're going to plug in a 4, and I'll continue this on the next slide. So I'll redraw our number line here real quick. So negative 3 and 3, negative 3 and 3, and we picked 0, 4, and negative 4, and we're analyzing f prime of x. Okay, so here we came up with a positive number, here was a negative, and now we're plugging we're going to plug a positive 4 in for the f prime. So this is going to be 3 times positive 4 squared minus 27, which is actually going to turn out to be the same thing as when we plugged in a negative 4. So that's a 21, so that is definitely a positive number. So now we have a plus above the 4 as well. Okay, so that is basically it, except for here's the analysis part. So what we're going to do is analyze what does this even tell us. So this thing here, this is basically the most important thing about the sign analysis, about the first derivative test, right? So on this interval, what can we tell us? What does that tell us? Like I said, to the left here, that just basically just keeps going to negative infinity, and to the right, this keeps going to positive infinity, right? So what we can say, this is a little bit more than, well, okay, I'll just start with identifying, analyzing those critical points. So again, here are critical points. This was negative 3 and a positive 3, right? So those were, remember, x equals negative 3 and x equals positive 3. Those were our 2 critical points. And at each of these points, we have to determine what's going on with our graph. So at negative 3, we see the first derivative changing from positive to negative, right? So when the f prime of x changes from positive to negative, that means we're going from increasing function to, here's our critical point, to decreasing, right? So at that point, we have a local maximum, okay? And conversely, when we go from negative first derivative to a positive first derivative, that means we're going from decreasing function and then to increasing, all right? So that is a local minimum, all right? So that's basically the solution or the answer to our problem. So we have when x equals negative 3, then we have that we're at a local maximum, okay? And when x equals a positive 3, that means we're at a local minimum. Okay, so that's basically it. And one more side note on this, I'm just going to go a little bit further to explain our sign analysis. What I was saying about the negative infinity and positive infinity is that we can kind of break up the whole number line into our intervals based on the critical points, right? So what I'm going to do is draw this huge line at negative 3, okay? And I'm going to make this line at positive 3 be bold as well. And so here's one interval, here's a second interval, and here's a third interval, all right? So let me show you, again, this is like a bonus part to the problem here. It didn't ask for this, but I'm going to explain it anyways. So here's our number line. Remember, I just cut it at negative 3 and 3. So negative 3 and 3, here are our lines. This was positive, this was negative, and this was positive, all right? And this is our f prime of x. That does not look like an f. There we go, f prime of x, okay? So what this means is that this interval here, which we can denote as negative infinity up to a negative 3, that means that our first derivative is going to be positive, which that tells us about our graph, the graph of our function. That means it is increasing, okay? So we know that f of x is increasing on this interval, okay? And then now let's look at the next interval, all right? So now we have the interval negative 3 to 3. We just denote it by the endpoints, right? So here we have that f of x is going to be decreasing. Okay, and lastly, here's our last interval. We have from 3 to positive infinity. That was a really weird infinity sign. Hold on. 3 to positive infinity. We have that f of x is back to increasing. All right, so that's pretty much it. Thank you for watching the little bonus section at the end of that problem. So that's all for the mean value theorem and monotonicity. And good luck on your homework and happy studying.
La, la.